Not all applications have the same network requirements. Some applications need to work in real time. Think of phone calls, Skype, Teams, and Zoom. You're talking to a person in real time. Your user experience relies on regular delivery of these packets. But there's applications like streaming video. That's things like YouTube and Netflix. It doesn't quite need to be real time, but for a good experience, if possible, you don't want it pausing and buffering. To learn more about voice and converged networks, take a look at our voice mini-series. And then there's transactional traffic. This includes traffic like web browsing, which uses the HTTP protocol. HTTP uses a series of commands or transactions to retrieve a web page for the browser to display. In short, applications have different needs. To address those needs, we must understand the different characteristics that affect them. In particular, we want to look at bandwidth, loss, latency, and jitter. In networking, bandwidth refers to the amount of data that needs to be transferred. We measure the maximum bandwidth of a link by the maximum number of bits per second that it can transfer. Some applications, such as video streaming, need a lot of bandwidth. Others, like using SSH to manage a router, need very little bandwidth. Loss is where the traffic does not reach the destination. There may be several places along the network where traffic can be lost. We measure loss in the percentage of packets that didn't arrive. For example, if we send 1,000 packets and 990 arrive, then this link has 1% loss. Latency is the amount of time it takes for a packet to travel from one endpoint to another. A similar term, round trip time or RTT, is the time taken for a packet to reach the other end and for the response to come back. Latency and bandwidth are sometimes confused. Imagine it like a water pipe. The bandwidth is how wide your pipe is, and it controls how much water can fit into the pipe at any one time. The latency is like the length of the pipe, which affects how long it takes for the water to travel down the length of the pipe. Applications like HTTP are very tolerant to high latency. Others, particularly real-time traffic like voice and video, are more latency sensitive. An interesting one is jitter. This relates to latency. Latency measures the time for a packet to travel between two endpoints. Jitter measures the variance in this time. Imagine we measure the latency of 5 packets. Delivery takes 10 milliseconds, 20, 7, 55, and 37 milliseconds. We have a lot of variance between the smallest and largest delivery times. This is the jitter. Jitter is particularly destructive to real-time applications like voice and video. These need a steady stream of traffic. Of course, some jitter is normal. A lot of jitter means there may be a problem somewhere in your network. One possibility is that the link or a device is beyond capacity. This slows down the delivery on some packets. You can use your workstation to get some measurements. This can be helpful when troubleshooting a network issue.